This video is about determining the a value of a polynomial function. And the a value, of course, is the value right at the start of the polynomial, and it's often what is considered our leading coefficient. Okay, so here's an example. Determine the cubic function with zeros at -4, -1, 3, and the function at 1 has a value of 18. So let's write out what we know. First of all, we know that this is a cubic function and I have 3 zeros. So since it's a cubic function and I have 3 zeros, I know that each one of these zeros is of order 1. So let's just set that up. So I know that I've got some function, and I'm going to have a leading coefficient, which is a, of some sort. I don't know what that is yet. That's what we're looking for today. And because of what we learned in class today, I know that my zeros are going to fall at x plus 4, x plus 1, and x minus 3. And since this is a cubic function, these all have to be degree 1 zeros. I can't have any squares or cubes here, or else it would raise the degree of the entire polynomial, and since this is a third degree polynomial, I can have a maximum of 3 zeros. Okay, so now what we're trying to do is we're trying to find this a guy right here. So I look back at my questions for some more information, and I see that, hey, the function when it has an x value of 1 is going to be way up at 18. So that means that my x value is going to be 1, it's going to have a value of 18. So I'm going to sub that value in here. So it has the coordinates 1 for the x value, 18 for the y value, and I'm going to sub that in to my f at x function that I have here, x plus 1 and x minus 3. Okay, so wherever there was an x, I'm now going to replace with a 1, and whenever and because the function is at 18, the f at x gets replaced with 18. So I'm going to have 18 now is equal to a times 1 plus 4 times 1 plus 1 and times 1 minus 3. And of course now we can just easily do the math. So it's going to be a times 5 times 2 and times -2. And because I want a by itself, it's going to turn out to be 18 divided by the value of 5 times 2 times -2, which is 5 times 2 is 10 times -2 is -20. So it's going to be 18 divided by -20 is going to give me my a value. Of course, this has to be reduced. So 18 divided by -20 is going to be -9/10. So therefore, I know, oh, that equals a. So therefore, I know that my function actually has an equation of -9/10 times all of these zeros, x plus 4, x plus 1, and x minus 3. Okay, so let's see what happens then if we were going to graph this function right here. So here's what our function is. So let's do a really quick sketch of this function. Okay, so let's write out what the function turned out to be. We had the function at x was equal to -9/10 times x minus 3, x plus 4, and x plus 1. And if I'm going to graph this function, first of all, I recognize this is a third degree polynomial. So it's an odd function. And the other thing I recognize is that my leading coefficient is negative. So I've got an odd function whose leading coefficient is negative. So I know my end behaviors are going to go into opposite directions. So let's take a look at what this might look like. Just a quick sketch. And y. Okay, so I have an odd function and I have zeros at 3, -4, and -1. So let's put those zeros in. So there's a 0 at negative 4, a 0 at negative 1, and a 0 at positive 3. Okay? The other thing that I can do to help me graph this function is I can figure out what the y-intercept is. That's a big help in graphing this function. So the y-intercept is when I make x equal to 0. And so if I make this equal to 0, this equal to 0, and this equal to 0, then I just have to do the math. So the y-intercept would be negative 9/10 times negative 3 times 4 times 1. So 9 times 12 divided by 10. I'll do some reducing here. So I'll make that a 5, make that a 6. And so this is going to turn out to be 9 times 6, which is 54, divided by 5. So 54 fifths turns out to be at around almost 11. So 10 and some change. So way up here, I'm going to have my y-intercept. And sometimes that's helpful. All right, so I'm looking at this as an odd degree polynomial. It has a negative leading coefficient. So that means that my function is going to travel in this direction, like a negative slope. So I'm going to start up over here, and I'm going to end up down here in this quadrant. So it's going to look something like this. I'm going to start up over here. I'm going to go through negative 4. I'm going to come back up through negative 1. At some point, I'm going to hit that y-intercept. And then I'm going to come back down here through 3. And then my arrows indicate that I head off in those directions. So a bit of a sketch, not completely accurate, but I've got my zeros in the right spot, my y-intercept in the right spot. I've got my end behaviors doing the right thing, and my leading coefficient telling me that it's going from quadrant number 2 down to quadrant number 4.